Okay, now we're going to still be doing hypothesis testing, still for the mean, but now small samples. And so what that means is less than 30. So n will be less than 30. Okay, so sample size less than 30. Okay, now you're going to you'll use the same process as in 7.2. Okay, but in 7.2 you use inverse norm. 7.3 you use inverse t. In 7.2 you do the z-test. In 7.3 you do a t-test. So there you got the t, right? Sample size less than 30. So you use t. Everything's t. Okay. In 7.2 everything was z. So inverse norm, you're finding the z critical value. Here you're finding the t critical value. So you do the inverse t, inverse norm to find the critical value. You use t-test or z-test to find the test stat or the p-value. Now there's one thing that you need to do additionally when you're doing anything with t is you need to find degrees of freedom. Not always, but sometimes you do. Degrees of freedom is always the sample size minus 1. So let's focus now on finding critical values. Okay, just that. You're not doing a test yet. But when you do a test, you got to find critical value. Okay, so let's look at 3 scenarios. Okay, and notice they say find the critical value t naught. So notice there's t again, right? So they're giving you a hint. Hey, it's t, it's inverse t, not inverse norm. For a left-tailed test with alpha equals 0.05 and n equals 21. Okay, so you would use inverse t. You got to state the area, 0.05. Then you got to do the n minus 1 and say 20 for the degrees of freedom. Okay, so here's a picture, right? You're using 0.05. When you do inverse t, you get this for your critical value. Now remember, that's your cutoff for when you're doing your test. Okay, do you get a number in your test that's to the right or to the left in this area over here? Next scenario, right-tailed test. So same scenario, same numbers, still going to do 0.05. Still going to do sample size of 21, so our degrees of freedom is 20. So what I like to do, so even though it's right tail, I do exactly the same thing. To me, it's just easier to put in the 0.05. You're going to get that negative, but now make it positive. Okay? Because it'll just be just on the other side, on the positive side, instead of the negative side. Okay, scenario 3. Okay? Same scenario, but two-tailed. Now you have to cut alpha in half. There's 0.025, 0.025. Put them together, 0.05. But when you do inverse t, you got to do 0.025. Okay? Because you're using 0.025, you are going to get this critical value, t critical value. Same degrees of freedom in this case. Okay? So here's what you get. It's negative. But then what you do is you just use the negative and use the positive. So use both, negative and positive, for your critical values.